So we have a beam of spin 1 of atoms which is going through a series of Stern-Gerlach experiments, and the first measurement accepts the Sz is equals to h bar 2 atoms and rejects the minus h bar 2 atoms. So what does this look like? Say this is Sz, these are plus h bar 2, minus h bar 2. This is blocked. Again, this is moving forward. What does it say? Second measurement accepts Sn is equals to plus h bar 2 atoms and rejects this one. And finally, there is third measurement, which is again Sz, but this time this are blocked, and this is what they observe. So the second experiment is actually not fixed in terms of angles, and that is what they are asking, that if the final intensity of this needs to be maximum, what should be this angle beta? This angle beta is with the positive uh, z-axis in the xz plane. So this is your state plus, this is your state minus, and this state here is the one that we derived earlier, the positive part. Okay, right. But there is a hidden assumption here that this beam is unpolarized, which means that there is no net angular momentum in any direction. And the state which reflects this aspect is the maximum unpolarized state. So this is how we start. So when we say that in the first part the plus h bar 2 atoms are accepted, let's say there is an initial intensity I0, is I1, I2, and IF. So the initial intensity of atom will be I0 by 2, because because 1 by square root of 2 square of this is what is related with, okay, so c plus mod square is equals to c minus m square is half, which is your probability amplitude or intensity. The first intensity is half of the initial intensity of the uh, atoms, and the state, this is intensity, and your state From this psi state, it becomes only a plus state with this much amount of intensity. Next, this state is now filtered through a state. We just say it like this. From previous exercises, we know how this is represented. Since the n is only in the xz plane, so your alpha becomes 0. So your state is only this. From that also we are taking only the this part, because this will be the plus h bar upon 2. The minus one is the blocked. So we need to take overlap of the state this and only this. So what this will give us? This will give us cos theta by 2. But we are interested in the amplitude. So it will be cos square theta by 2. So now the intensity by 2 is what? It is I1 times cos square by 2. Okay. In the final phase, we need to see the overlap with the negative state and some plus state and the mode square. So that will give me this sine beta by 2. And this will be square will be sine square beta by 2. So intensity, final intensity will be I2 times sine square by 2, which is 1 by 2 by 0 cos square by 2 square by 2. Four, 0 by 2. Okay. And sorry, it's beta. Okay, yeah, this V1 by 8. Okay. They have asked that if initial intensity is normalized to unity, then the final intensity is 1 by 8 sine square beta. And for this to be maximum, beta should be pi by 2. So the final intensity is 1/8 the maximum possible intensity.